Hello my dear students, this is Akash HD and welcome to the ASD physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the questions from the topic Carnot engine. Very important. Let's go through the question. So the question is, a Carnot engine operating between two reservoirs has efficiency 1/3 when the temperature of core reservoir raised by x, its efficiency decreases to 1/6. The value of x if the temperature of hot reservoir is how much here? 99 degrees Celsius. So we have to get the value of x. Remember that here students, in any heat engine there is used to be the hot reservoir, cold reservoir, and this engine used to do some work. How this happens that here? Kindly see here please, then only we can do this question. What is this? Is the engine please. Now this is the engine. This engine takes the heat Q1, okay, from the which reservoir? Hot reservoir at temperature T1. Hot reservoir, okay. Even this is called a source also. What is called? This is called a source. After that, what will happen that here? This will do some work, okay, and the rest of the heat, that means Q2, it will transfer to the which reservoir students here? That is called the cold reservoir, okay, and even sometimes this is called here the sink also. Okay, so what happens that here students, if I talk about here the efficiency, so efficiency of this is always given by output W by Q1, that means work done in each cycle by the heat supplied Q1 from the hot reservoir. But students, after that when you will apply here the conservation of energy, so you can see very well the Q1 heat is going and W we are getting and then Q2 is getting. So we can tell Q1 equal to W plus Q2. What I am telling that here? I can write here Q1 is equal to W plus Q2 from conservation of energy. So from here W is what is there? We can write here Q1 minus Q2 by Q1, okay, and it will become here 1 minus Q2 by Q1, okay. This is the efficiency. After that what happens that here students, if in case this efficiency is the maximum, na Carnot engine. In case of Carnot engine, what happens that here students, in case of Carnot engine, the efficiency of the engine is maximum, and for the maximum efficiency it will be always, remember that here, Q2 by Q1 will be always equal to T2 by T1, okay. So hence we can write here this maximum efficiency. How much is there? This maximum efficiency is given by what? 1 by T2 by T1. This is the maximum possible efficiency of any engine. The engine efficiency cannot be never 100%, okay. Carnot engine is based upon the 4 steps like isothermal expansion, then adiabatic expansion, then isothermal compression, adiabatic compression, and all that. 4 steps are there. But anyhow, the maximum efficiency possible, how much is there? 1 minus T2 by T1, okay. So depending upon the question students, if I write here, see here, in the question they have given here what? Efficiency, how much is there? 1/3. So eta 1 is given here 1/3. And let's take the temperature of the cold reservoir is how much here? T2, okay. Now after that students, here in the question they have given here efficiency is becoming how much is there? 1/6. This is happening when this temperature is increased by x. So it is becoming here T2 plus x, okay. So what they are asking here? They are asking here the value of x. So here we are going to use here the formula. The formula we know very well now. So see, first one we'll use here. We know efficiency is given here 1 minus T2 by T1, okay. So eta how much is given there here? First one, no? First one it is given here, see, 1/3 is equal to 1 minus T2 by T1 value. T1 value you can see very well, the value, the temperature of the hot reservoir is given how much here? 99 degrees Celsius. We have to convert into Kelvin, that means we have to add here 273. So 99 plus 273 will become here 372, okay. So this is becoming here 372. This is the equation 1, okay. After that what is happening that here the students, this new efficiency eta 2 when this temperature of the sink is increased by x, okay, there is no change here T1, okay. So in this situation students, it is given here 1/6 is equal to 1 minus, can you separate this here? T2 by T1 minus x by T1, is it? Now what will happen that here? Kindly see here, this is the 1/6 is equal to what is this value? 1 minus T2 by T1. What is given here anyhow? We can write here 1/3 is equal to minus x by T1, okay. Then after that what will happen that here? Can you simplify this? It will come here x by T1 is equal to, we can see very well, 1/3 minus 1/6, is it? Just kindly take here the LCM. So it will become here the students x by T1 is equal to, after taking LCM, 1 by 6. So hence if I write here the x, this x will come here what? T1 by 6, T1 value, and here how much is there? This T1 value is the 372, 99 plus 273. So it will become here 372 by 6, and we can write here 6 6 are 36, this will go that side, 62 Kelvin. Okay, so what is this? The value of x is going to be very well, you can see very well students, the value of x is going to be, how much is there? The value of x is going to be the 62 Kelvin. No? Can you see here? Very well. No? So this is the first kind of question. After that, what is happening students here? Here you can see, here also same basic we have to use. The question is what? Can you see very well? A Carnot engine with efficiency 50% take heat from a source at 600 Kelvin. In order to increase the efficiency to 70%, keeping the temperature of sink same, the new temperature of the source will be how much? Is it? So in this question students, first let's note down the data very well. What is given here? Efficiency. First efficiency they have given here 50%, that means 0.5, and source temperature how much is given that here? See, T1 equal to 600 Kelvin. Okay. Now what is there? They want to increase the efficiency to 70%. That means see, this eta 2 is how much is given here? 70% means 0.7. Keeping the temperature of the sink same. Okay, so let's take here the sink temperature is T2, and here also what is there students? See, this T2 equal to T2, there is the no change, even the T2 dash also is the same only. After that, what they are asking here, the new temperature of the source how much is there? They are asking here the value of T1 dash how much. Okay, so this is the question situation. Okay, so students, we can see very well, again note down the situation. The first situation is what's here? Eta is equal to 1 minus T2 by T1. First one we are going to solve for the eta 1. Okay, so eta 1 how much is given here? Kindly see, 0.5. So 0.5 is equal to 1 minus T2 value as it is, T2 by T1 how much is given here? 600 Kelvin, always in a Kelvin. Okay, so students, when you will simplify this, it will come here T2 by 600 is equal to 1 minus 0.5, that means 0.5. Okay, so what is the value of the T2? 0.5 into 600, that means students, it is coming here 300 Kelvin. This T2 value we have got is there, na? And this value is not going to change when we are going to make the efficiency 0.7, is it? So what I will do here, again we will use the formula here students. Can you see here? This now eta is equal to 1 minus, we can write here T2 by T1, and here eta 2, let's take T2 dash, and here T1 dash. Okay, so eta 2, what they are telling now, they want to make the efficiency 0.7. Okay, so see this here efficiency is the 0.7 is equal to 1 minus, and T2 dash value we have to keep it same, no? That's the sink temperature 300 by the new one is the T1 dash. Okay, so students, when I will simplify this, what this will become here? See, 300 by T1 dash is equal to 1 minus 0.7, that means it will become here what? 0.3. Okay, so it will come here T1 dash is equal to 300 by 0.3 students. Just simplify this, it will come here how much? 3000 by 3, and hence this T1 dash value is going to be how much students here? 1000 Kelvin. How much here? 1000 Kelvin, is it? So you can see very well which option is correct is there. The correct option is here option B. Is it 1000 Kelvin? Okay, and you can see here very well in how much beautiful way we have got here the new temperature of the source. Okay, and here the same, this kind of question is also very important in the exam. Can you see here? See the last question. Work done by a Carnot engine operating between temperatures 127 degrees Celsius and 27 degrees Celsius is the 2 kilojoule. The amount of heat transferred to the engine by the reservoir is how much here? Okay, so what I am going to do here, let's note down the data is there. The temperature of the source they have given here how much here? 127 degrees Celsius, add 273. So students here 127 plus 273, what this will become here? I think so it will become here 400 Kelvin. Okay, after that, if I will write here the temperature of the sink cold reservoir, how much is given students? 27 degrees Celsius. Okay, so again kindly add here the 273. So what this will become here? It will become here the 300 Kelvin. Okay, the amount of heat transferred to the engine how much here, and work done how much is given? 2 kilojoule. Okay, so work done is given here 2 kilojoule, and they are asking here how much heat supplied to the engine from the hot reservoir. That means Q1 value we have to calculate. This is there. Okay. So now what we'll do here, students, can you see here? We know eta equal to 1 minus T2 by T1. Correct na? Is it? And if you will see the basic, eta means efficiency, output by input. What is the output, students, here? W. Input is the Q1, is it? And it is the 1 minus T2 by T1. Okay. Can you remember that? This formula is the very important. In number of questions, we have to use this formula. Okay. And after that, when we will simplify this here, kindly see very well, students. W, how much is given this there? W is the 2 kilojoule. So 2 kilojoule by Q1 is equal to 1 minus T2, how much is given? 300 by 400. So 0 cancel. So 1 minus 3 by 4, is it? And when you will simplify this, it will come here how much here? 1 by 4. Okay. So if I write here the Q1, Q1 will become how much is there? 1 minus 3 by 4 means 1 by 4, and this 4 into 2, it will become here how much, students? 8 kilojoule. Now, kindly see very well how we have got here the 8 kilojoule. That means the which option is the correct option? The correct option is going to be the option D, students. So I hope so, students, this questions based upon the Carnot engine you have understood very well. Keep studying, keep growing.